Hi, good afternoon, everyone. Thanks for joining us. I'm Allison Slack, Manager for Manufacturing-Related Strategic Initiatives at FuseHub. FuseHub is a not-for-profit organization that connects New York State's small and mid-sized manufacturing companies to the resources and programs and expertise that they need for things like technology commercialization, innovation, and business growth. Essentially, we help companies navigate New York's robust network of industry experts at manufacturing extension partnership centers, university research centers, economic development organizations, and other providers. Sorry about that. So FuseHub is the statewide New York Manufacturing Extension Partnership Center. We are supported by Empire State Development's Division of Science, Technology, and Innovation. And our two organizations work together very closely. Today, we're here to discuss a few of the Manufacturing USA Institutes and help you understand the opportunities that they might present for your company. The Manufacturing USA Network consists of 14 federally supported institutes across the country that are focused on R&D in different areas of manufacturing technology. They are public-private partnerships in which industry, academia, and government are co-investing to solve manufacturing challenges with the goal of enhancing industrial competitiveness and boosting economic growth in the United States. New York State, so everyone knows, is home to 3 headquarters of Manufacturing USA Institutes, which we're proud to say is more than any other state, and New York State has invested more than any other state in the network. So even for institutes that aren't headquartered here, some of our exceptional New York State universities are leading members of the institutes. You're going to be hearing about 5 of those institutes today. Some of our presenters are personnel from the institutes themselves, and some are employees of the New York Manufacturing Extension Partnership Network. That means they are supported through grants from the Department of Commerce's National Institute for Standards and Technology, and they are responsible specifically for engaging more small manufacturers in the work of the institutes to help them benefit from these new technologies and participate in their advancement. For all the attendees out there today, please feel free to submit questions. We will have a Q&A at the end. And you do that by, in your GoToWebinar control panel, the questions section, please send us a note and we'll save those for the end and have the panel address all the questions that we have time for. With that, I'm going to turn it over to Kevin Kelly, who's going to talk about the Remade Institute. Thanks, Kevin.
Thank you, Allison. Much appreciated. So my name is Kevin Kelly, and I am the Director of Sustainability and Business Development for the Remade Institute. Remade is one of the institutes that is headquartered in New York State. We're in Rochester, New York. And so I'm happy to take this opportunity to talk to you today. Next slide, please. So in terms of the Manufacturing USA infrastructure, Remade is one of the newest institutes. We were announced in January of 2017. And each one of the institutes that's participating in Manufacturing USA has its own area of focus and specialty. The mission of Remade is to enable the early stage applied research and development of key industrial platform technologies that could dramatically reduce the embodied energy and carbon emissions that's associated with industrial scale materials production and processing. The Institute itself is set up as a consortium that promotes collaboration between our various partner organizations. Our members include representatives from industry, academia, trade organizations and foundations, and resources from the national lab infrastructure as well. In addition to our technology focus areas, the Institute is also making a national impact with respect to training initiatives and with respect to workforce development opportunities that will focus in on some of the breakthroughs in manufacturing and related fields. If I take a look at what I mean by our advanced technology development, what we're looking to do is we've got 3 main planks that we have here with respect to the reduction of utilization of the promotion of secondary feedstocks through the reduction of primary feedstocks. We are also trying to take a look at promoting widespread application of new technologies across the various industries that we participate in to expand initiatives with respect to recycling, recovery, remanufacturing, and reuse. The Institute itself is looking to develop technologies that will increase secondary feedstock utilization by at least 30% while reducing primary feedstock consumption. We're looking at technologies that are capable of delivering cost parity for secondary materials, and also looking to achieve significant improvements of 25% or more with respect to embodied energy efficiency in the first 5 years of the Institute's inception, and then 50% reduction 10 years out. We also have objectives to reduce the energy demand that's associated with the secondary feedstock processing, and looking to make improvements by 30% in our first 5 years. And then also try to have a 10% reduction in terms of primary feedstock material usage over the course of time as well. We're expecting that this institute itself is going to make some significant impacts, and these 3 planks that we have listed here for our advanced technology development is kind of the earmark that we're starting with in terms of the initiative. If you flip to the next slide, please. This slide, it's a little bit of an eye chart, but I thought that this is a great overall framework to kind of tie things together. So this is actually an output that we had from our technology roadmap. The Institute itself was architected with 5 main focus areas, and those are represented in the vertical columns in gray, and along the top you see the headings. And what we've got is 4 of our nodes or focus areas really aligned to the material life cycle stages, and that's design for reuse and reassembly and remanufacturing. These are tools that are meant to improve the material utilization of the overall process itself, and it has to be done at the design phase up front. We have a materials optimization node that involves technologies that will reduce in-process losses and reuse of scrap materials, and then promote the utilization of secondary feedstocks in manufacturing. Our third node involves remanufacturing and end-of-life reuse, and that deals with efficient, cost-effective technologies for cleaning, component restoration, condition assessment, and even the reverse logistics that goes into the acquisition of core. We have our fourth node is recycling and recovery, and that involves the identification, sorting, separation, contaminant removal, reprocessing, and overall disposition of items. Our fifth node is kind of what we look at as the thread in the needle of being able to tie all of those other nodes together, and that's our systems analysis and integration. This node focuses on the development of consistent set of protocols, data sets, and tools for quantifying material flows and the life cycle impacts of the various institute activities. As we were going through our technology roadmap, based on the voice of industry and our other member participants, we wound up finding out some cross-cutting themes that emerged during this development process, and those are depicted along the horizontal planks that are in color. And just to kind of go through it, we started out with the materials processing and recovery techniques. These are technologies that are used to manufacture, recycle, recover, and reprocess materials, and those cut across all of the nodes. Characterization, qualification, and inspection. These are approaches to ensure that the composition, quality, and purity of feedstocks and the condition of cores and components is done in a consistent manner. Simulation, engineering, analysis tools. These are obviously science and engineering-based tools that inform how to most effectively manufacture, recover, reuse, remanufacture, and recycle materials. Value chain and integration impact. This is an evaluation methods that will optimize the material product flows and quantify energy emission reductions for the use and promotion of secondary feedstock, and also driving energy parity with respect to secondary feedstock versus primary feedstock. And our last plank is workforce development, and that's one of the aspects that involves the training and education activities that basically help prepare incumbent and future workforce with respect to our remade relevant technologies. If you flip to the next slide, please. Here we've got, I just wanted to touch on an example of a project activity that is actually something that is engaging with Remade. We have a company, a small company, actually less than 10 employees, called EDX Magnetics out of Utah, that's been selected for a $1.1 million foundational project through the Institute. The goal of this project is to improve non-ferrous metal separation recycling through a process called electrodynamic sorting. The process itself uses eddy current and magnetic separation technologies and combines them into one step, builds off of a previous ARPA-E funded initiative, and it addresses the issue of scrap metal separation, which has been deemed an important topic for the Institute. And the project itself has received significant support from our independent review committee and subsequently was selected for this funding initiative. We anticipate as a result of the project itself that it's going to enable an increase in aluminum scrap particulate recycling capability. And while doing so, they're going to upscale the process capability from lab speed capabilities into an industrial-based inception concept. This electrodynamic sorting enables the separation of absorbent and twitch, and if it can be done effectively and demonstrated as they anticipate, the scrap values associated with the product will actually increase by 3 to 5 times through the use and implementation of this technology. The Institute, for the Remade Institute itself, was set up with small and medium companies in mind. We created a provision within our industry membership that allow SMEs or small and medium enterprises to participate with the benefits of full membership that the large industry participants will have, but at a much lower cost point. And when I reference a lower cost point, I'm talking on the order of only 5 to 10% of the total cost of the large company counterparts. We actually have our Tier 3 membership inception level gives people an opportunity to get a foot in the door at only $1,000 annual cost. Today, we've got 58% of our total industry membership consists of small and medium-sized companies. We've got a couple of great small companies that are based right here in New York State that have been active participants in the Institute since the beginning. And they're also, it's great because we're seeing diversity in terms of the member partners. So we have Sun King based out of Brockport, dealing with the recycling industry. And then we've got Davies Office Furniture out of Albany that is actually one of the leading furniture remanufacturers in this country. So the SMEs that are involved in Remade really span the gamut of activity that we're seeing in terms of industry. If you flip to the next slide, please. If we have an opportunity here just to try to touch on membership opportunities, and I want to point folks to the Remade website, which we've got listed below. If anyone would be interested in finding out more about our membership perspectives and whether or not this is a fit for your organization, we certainly encourage you to visit the Institute's website. We have a membership inquiry form that provides some additional information to kind of supplement some of what I touched on very quickly today. And we encourage folks to go ahead and visit the site and take a look at that. The membership inquiry form has actually got an embedded link right in this, so once you get the slides, that will be available to guide you directly to that. And with that, I will turn it back over to Allison, and thank you all for attending today's event.
Thanks a lot, Kevin. Appreciate it. Next up, we have Adrian Kozma of FuseHub itself to talk about the Clean Energy Smart Manufacturing Innovation Institute. Adrian?
Hi, my name is Adrian, and I'm the Smart Manufacturing Lead for the Northeast region. I am here to talk to you about the Clean Energy Smart Manufacturing Innovation Institute and smart manufacturing. SESME is funded by the DOE. They have 5 locations throughout the United States. They are headquartered in California, and I am based in the Northeast region at RPI. The goal of SESME is to revitalize U.S. manufacturing by having an impact on reducing energy usage, increase productivity, and economic development by developing advanced technology, improve workforce development, and increase performance in manufacturing. There are many definitions of smart manufacturing, and one way to think of smart manufacturing is smart manufacturing enables you to plan, envision, deploy solutions to improve business operations. Smart manufacturing is a tool that will help you make better, faster, and informed decisions based on data. If you're a manufacturer and you've thought about, I have all this data, but it is all over a dozen different databases, the Smart Manufacturing Platform will help you aggregate all data onto one platform. What does this data even mean? The Smart Manufacturing Platform will enable you to analyze your data and provide you with summaries. I like to be able to predict when a component will fail. That recall last year was devastating. Through sensors, you can anticipate product failures and avoid those costly recalls. Now, how can I make better and real-time decisions? I do not have time to wait for data analysis. The Smart Manufacturing Platform looks at your equipment and processes real-time, and it will empower you to make decisions on the spot based on data analytics. The goal of SESME is to develop this Smart Manufacturing Platform that can enable manufacturers to adopt different smart manufacturing technologies to improve your operations. The Smart Manufacturing Platform is like a business health record system. There are enabling technologies such as sensors and data analytics that will allow you to improve your business process, your workforce development, and technologies. They work together in harmony. The outcome is improved overall performance, increased productivity and efficiency, making manufacturing faster, better, cleaner, and more profitable. Here's an example of a smart manufacturing technology. There are smart manufacturing technologies that can be installed by you, the manufacturer, in your facility. This is a great example of new technologies that are non-intrusive and does not cause disruption in your operation. This will enable you to make better and faster decisions and pinpoint any problems you may have. In this example, the manufacturer self-installed cameras and sensors where the employees have sensors the size of a credit card in their pockets to monitor their activity on the shop floor. Now you're able to collect data real time. This enables you to understand your workflow better by analyzing loss in production time, bottlenecks, and what is causing the variability in production. This is just one example of many on how smart manufacturing can help improve your operations through data analytics. Now you ask, am I ready for smart manufacturing? Well, if you have thought about improving your business goals and are worried about new regulations, or there is greater demand for your product, and if any of those boxes are checked off from the list, then you are ready to start thinking about smart manufacturing. We have developed a smart manufacturing assessment that is quick, easy, and free. The goal of this assessment is to get you thinking about smart manufacturing and meet you where you are in the smart manufacturing journey. Please feel free to email me or call me anytime with questions regarding smart manufacturing and how I can help. And the link to the assessment will also be posted on the website when the webinar is posted. Thank you again for your time.
Thanks, Adrian. And at the end of the webinar here, we'll have a slide with everybody's contact information again. And now I'd like to turn it over to Terry Class with Empire State Development to talk about the American Institute for Manufacturing Integrated Photonics.
Thanks, Allison. Good afternoon or good morning, everyone. So I am Terry Klass, and business development representatives for Photonics in the state of New York, working in the Science, Technology, and Innovation Division. So next slide, Allison. So the American Institute for Manufacturing Integrated Photonics, or AIM Photonics, is an industry-driven public and private partnership that focuses its work to accelerate the transition of integrated photonic solutions from innovation to manufacturing-ready deployment in systems spanning commercial and defense applications. AIM Photonics supports large, small, and medium enterprises, providing practical access and technology on-ramps for U.S. industry, government, and academic communities. They are creating a national manufacturing infrastructure accessible and flexible to meet the challenges of the marketplace with practical and innovative solutions. Now, just a bit about the technology. So we're talking about photons, or particles of light. And this technology includes sources of light, such as lasers, LEDs, waveguides to guide light, such as fiber optics, and a variety of optoelectronic devices that encode digital information onto optical signals and convert optical signals to electronic ones. These devices are fabricated as an integrated structure onto a surface of a flat substrate, in this case, silicon. So photonic circuits can now process and transmit light in similar ways to how electronic integrated circuits process and transmit electronic signals. So there's my Physics 101 for everyone. Allison, next slide. So the Institute really has 5 key manufacturing areas: data centers and telecom, RF analog applications, sensors for medical applications, sensors for autonomous type vehicles, and phased array image technology applications. So the common need or goal of all of these industries or markets is essentially how much data can be processed at what speed, over what distance, using what power, at what cost. And the graphs in the center just illustrate those variables when compared to photonic solutions versus electronic solutions. And the essence is photons are advantaged over electrons. Next slide, Allison. So again, the Institute is sort of looking or engages with what I consider 5 categories of companies. So on the far left, upper left, it would be the applications or systems companies. These could be your cloud-based companies like Facebook, Amazon, Google, etc. And they are obviously looking for those goals which I mentioned before of how much data can be processed at what speed, at what cost, at using what power. And they're eventually looking to market unique application systems with differentiating capabilities. Over to the top right are the product type companies, and I'll use a transceiver as an example of a product which again can take electronic signals and convert it to photonic signals and vice versa. And they, of course, go into these large cloud-based systems companies which utilize transceivers to process that type of information. Bottom left would be the manufacturing companies. These could be contract manufacturers that do the actual fabrication of the components, that do a test assembly for these types of products, as an example, would support a transceiver type company in those contract manufacturing type services. And the bottom right would be an equipment company that may provide tools and capabilities for the Institute or for other companies that are engaged in integrated photonic manufacturing. Next slide. So an example, 2 examples. First is we'll talk about chemical and biosensors. And so for everyone, photons can be used to detect and differentiate the optical properties of materials. They can identify chemical or biochemical gases from air pollution, organic produce, and contaminants in water. They can also be used to detect abnormalities in our blood, such as low glucose levels, and measure biometrics, like our pulse. So the example that I'm illustrating here is actually Dr. Ben Miller out of the University of Rochester is developing a sensor utilizing an integrated photonic chip. And think about when you go to the doctor today, he draws blood or she draws blood, they send it to the lab, and X number of days, you get those results back. Well, using this technology, it will be possible to have in the doctor's office, or even eventually, I think, in your home, where you could get results from your blood instantaneously, which of course would be a great benefit, not only to the doctor, but of course to the patient. So essentially, they're trying to engage these sensors with practices that better protect our environment, monitor our food supply, and keep us healthy. This is just one of the applications. Next slide, Allison. So the next is these data centers and telecom market type applications. And I think most of you know these large, massive cloud computing data centers, and they store and process the information that we live by. And of course, these cloud-based services have much more demand, as we now have many more wired and wireless networks. And so when you lift up the hood of these cloud-based companies, you see these components that support these Amazon, Google, and Facebook type companies. And this is the transceiver type application. And using an integrated photonic chip, you could see these the speed and performance requirements that these cloud-based companies demand to have these 5G transmission rates. So again, there are companies throughout the country, but certainly here in Rochester, that are leveraging these integrated photonic chips to build the transceivers that will be a game changer, I think, for the data centers and telecom market. Next slide, Allison. So how to engage? There's essentially three people that I'd like to call out. One is myself, of course, and my contact information is there. The second is Ed White, who's the corporate outreach executive for the AIM Photonics Institute and is also the vice president of the test assembly and packaging facility. And the third is Madeline Glick, and I encourage everyone to visit the AIM Academy. They have a great wealth of information for the beginner to the expert in terms of videos and webinars and other educational information. And you can get to the AIM Academy from the AIM Photonics website. And again, just a wealth of information, and they work on workforce development and road mapping type of activities. And again, a great resource for everyone on the webinar. Again, I'm sure there'll be questions at the end, but Allison, I think that's the last slide.
Thank you, Terry. Next up, we have Scott Miller, who's based in upstate New York, nearby where we are sitting, and a representative of the institute known as NextFlex. Scott?
Hi, thank you very much. This is Scott Miller, and I'm the Director of Strategic Programs at NextFlex, the Flexible Hybrid Electronics Manufacturing Institute. I'm happy to have a chance to talk with you today about NextFlex and what we can do together. So NextFlex is based in San Jose, California, and we have a strong nationwide footprint. And as a note, yes, I am based in Clifton Park, New York, not too far from Albany. If we can go to the next chart. So NextFlex's mission is to accelerate the growth of the American manufacturing ecosystem for flexible hybrid electronics. Flexible hybrid electronics, or FHE as we refer to it, integrates printed and additively manufactured circuit elements with bare die integrated circuit chips, or dies, that enable thin, flexible, lightweight systems with the equivalent functionality to rigid printed circuit boards. So the pictures on the right-hand side of this chart show an Arduino, which is a microcontroller board that's commonly used by hobbyists and the maker community to add intelligence and control into products. So these devices these are devices that you can find in even a lot of high schools today. So they're very common and widespread. Just as a demonstrator of what can be done and what's possible with FHE, NextFlex recently developed a flexible version of the Arduino that's shown on the far right to inspire thought about what these new form factors could enable. This is a device that you can take, you can wrap it around a small diameter cylinder, for example, roll it up and put it inside of something. So NextFlex is a nationwide network of members. We have industry, academic, and nonprofits like economic and workforce development organizations. And as I mentioned, we're headquartered in San Jose, California. Out in San Jose, we have our technology hub, which is a prototype and small volume manufacturing pilot line for FHE. And the purpose of that facility is to advance manufacturing capabilities and demonstrate the processes and product capabilities in partnership with our members. So one example of a success that would come out of there is helping to grow any of the things that we're doing at the hub to the point where it outgrows our facility and moves into one of our members' commercial operations. The map that you see on the lower left shows that the large concentration of members that we have in the Northeast, in particular in New York and Massachusetts. And many of the members in this region are very active and partner with other member companies to advance FHE technologies. If we can go to the next chart. To enable the manufacturing ecosystem for FHE, the Institute organizes its focus into 10 technical working groups. We group these into manufacturing thrust areas, which are the technologies that allow FHE devices to be made, and technical platform demonstrators that are examples of the application spaces that can be impacted by FHE technologies. Essentially, these are sort of the how and the what of flexible hybrid electronics. So the manufacturing thrust areas that we have are device integration and packaging, printing and microfluidics, materials, modeling and design, standards, test, and reliability for the manufacturing thrust, and then the 5 areas of technical platform demonstrators, which are really just 5 out of many, many examples, are integrated array antennas, human performance monitoring, asset monitoring, soft robotics, and flexible power. So we organize our technical community into these 10 technical working groups. Each has an industry, an academic, and a government lead. And then the technical working groups have developed roadmaps that identify what's possible today and what's needed at different times in the future in order to achieve the industry's goals. Then we work collectively, for example, by creating funding opportunities for members to work together to close the gaps that are identified on those roadmaps. And then as a final note on this chart, in addition, since our goal is to grow the entire ecosystem, we need a workforce that can do that as well. So NextFlex has a very robust workforce education and development activity that includes elements targeting high schools, community colleges, universities, and the existing workforce. If we can go to the next chart. So we currently fund more than 30 projects across a full set of roadmap gaps. I've pulled out 4 examples to try to cover a diversity of our focus. We're very proud that our projects bring together members in ways that really couldn't have been possible without the Institute. And so every one of the 4 examples that I have on this chart includes a small or medium manufacturing business that you'll note 3 of those are actually based in the Northeast, in New York or Massachusetts. And each one of those is contributing very significantly to the project that's being done and receiving funding through the Institute. So every project that we do is a co-investment by the Institute using our federal funding and by the members who are performing the project. And it's worth noting that New York has been very generous in providing additional support for work that's done in the state of New York on NextFlex projects. And we can help make connections for you with respect to that. Now, as you might expect, small businesses are very concerned in protecting their intellectual property. And our IP agreement was developed with industry, and we believe it's very favorable. As one example, members own the intellectual property that they develop on the projects that we fund. So I'll just walk you through these 4 projects very quickly. On the upper left side is actually a piece of flexible hybrid electronics prototype and production equipment that's being developed on a project led by the Rochester area business Sensor Films. They're a small business out in Western New York. And they're working with a large collection of partners that you see there that include some research organizations, large companies like Boeing and GE, as well as Jabil, which is one of the largest electronics manufacturers in the world, and some other small equipment companies where they're bringing technology from those companies and integrating it into this all-in-one tool, as well as universities to support them. On the top right, you see a printed X-band array antenna. This is a military communication style of antenna that's being developed through printing technologies by the company in the Boston area called SI2, another small business, with their partners. In the lower right corner, it's a project developing some additional equipment for flexible hybrid electronics manufacturing, as well as the materials that go along with it. In this case, it's an inkjet printing-based process for printing electronics developed by Meyer Burger. And in this case, the small business tie that I'm showing here is another New York-based company, Intrinsic Materials, where they're developing some very novel nanomaterials for printing copper. On the lower left-hand side is a flexible smart asset monitor. This is essentially a sticker-like tag that relies on printing and converting technologies as one part of its manufacturing, and then thin silicon dies as the other piece, where this company, American Semiconductor, is working on developing a process by which they can thin a silicon die to the point where it becomes mechanically flexible and can be incorporated into a very thin tag. So if we can go to the next chart, it'll be my final chart. And there are many ways to get involved in with NextFlex. So the first way is through membership. Our members identify the needs that, to be filled, and we then work together across those needs. And so there are many ways that members can be actively involved with the Institute. Next, we run workshops around the country on a variety of specific FHE topics. As two examples, we've held workshops recently on human health monitoring and flexible power devices. And these workshops are open to members and non-members alike. Next, we perform sponsored R&D to help solve specific problems at our technology hub, or we can also make connections to our members around the country, including in this region, who can help with these sorts of activities as well. And then finally, if you have a product and you need to figure out how to make it or how to convert it into a flexible hybrid electronics format, we have the prototyping and low volume manufacturing capabilities to help do that. So I'd encourage you to contact me for more information about anything I've mentioned or with any questions you may have. And with that, I'd say thank you, and I'll turn it back over.
Thank you so much, Scott. And our final presentation is from John Wen at Rensselaer Polytechnic Institute to discuss the ARM Institute, which concerns advanced robotics. John?
Hi, my name is John Wen. I'm a professor at the Rensselaer Polytechnic Institute. I also co-lead the New York State participation in the Advanced Robotics for Manufacturing, or ARM Institute. We are also one of the newer Manufacturing USA institutes. We were awarded in January of last year. This team, the ARM team, was led by CMU at Pittsburgh. It's national in scope. New York is co-leading the Mid-Atlantic, what's known as Regional Robotic Innovation Collaborative, or RIC. We are co-leading the New York participation together with Fuse Hub. Next slide, Allison. Next slide. Yeah, there we go. Okay, so at ARM, we aim to address two key challenges. Number one is in the current manufacturing environment, the use of robots is actually quite limited, even though it's used quite extensively in automotive industry and a few other industry, but in many cases, its use is quite limiting because the lack of a common set of software and hardware tools. And the second challenge that ARM is addressing is a lack of skilled workers. ARM is addressing this challenge from two directions. First is by providing training to enhance skills of existing workers to better utilize the capability of robots and automation. At the same time, to develop robotic technology to work in dull, dangerous, and dirty environment. So the key underpinning pillars of ARM is technology development, workforce development, at the same time building a very robust ecosystem to support this technology. So the way ARM works is this. So by getting the input of the membership of this entire ecosystem, we go through a set of road mapping exercises to identify the needs and gaps of the current state of practice. From all of this set of road mapping exercises, a set of project calls, project needs are identified, and project calls generated. And this project calls basically are open to the membership to compete, to work on this project with ARM funding. But the results will be captured in a repository and shared among the membership to generate solution for the membership. Next slide, please. So let's drill down a little deeper of the ARM technology. So the key focus is to go beyond today's manufacturing robot. Today's robot is very expensive to program, essentially using a teach and playback mode. It's very inflexible to operate and very hard to tailor to different applications. And finally, it's isolated from humans, so it's hard. It's dangerous to have today's industrial robot to work together with human workers. So the technical thrust, the focus of the technology focus of the Institute is to address today's limitation. So there are 2 project calls each year. The first project call, it was announced in November of last year, and this is a result of a set of road mapping exercises. So you identify 7 topics, and the memberships are invited to compete for to propose projects along those topics, and they range from identifying a packing object, such as in parts kitting, to manipulation of compliant materials in topic 6, such as in composites manufacturing. Next slide, please. So I would talk about 2 project examples, and we are involved in both of them. The first one is a quick start project that was written into the proposal, and the Defense Department decided to fund this. And the focus is to develop robotic technology to help with large composite structure assembly. So currently, for such large structure that involve large, heavy, and curved, flexible loads, precision assembly is very difficult for robots, industrial robots, to achieve. So it's still mostly done manually. And we, together with GE and a number of other companies, small companies and nonprofits, are working on demonstrating and developing sensor-based robot control technology, both software and the demonstration that we can manipulate such large and heavy parts and still achieve very high precision assembly requirement. So that's currently funded, and we have just started on this project. Another type of project that goes to the other side of the spectrum is working with a small company that's not currently supported. This project is not currently supported by ARM, but it shows the potential of the mechanism that we can work with companies of different sizes at different levels. So for this project, it's supported by New York State, which generously supported the participation of New York State company in the ARM Institute. And the idea is to take a concept that the company has, which is a 2D laser sensor and mounted on a robot towards to produce capability for 3D inspection. So this is still early stage. So the idea is to generate preliminary results, which can in turn lead to the ARM Institute funding. So companies of all different needs at different level of technology, they can be involved in ARM Institute through various mechanisms. Next slide, please. So finally, I would like to encourage all of you who may be interested in ARM or robotics, or exploring robotics application in your environment, to talk to us. I think that the key is to first engage in conversation and identify your needs, whether it's technical challenges or you have education workforce training needs or business needs. And then we would help you to identify the best way, the most productive way to engage in the ARM Institute. So I'm John Wen, and Glenn Saunders is also our PI. So we work with Allison and Elena at Fuse Hub to help the New York State companies to engage in ARM Institute. So I'll stop here, and I'll answer any questions that you may have.
Thanks so much, John. Okay, that concludes our presentations, and we'll move into a Q&A session now. If you have questions and you have not yet submitted them through your GoToWebinar control panel, please go ahead and do so using the questions section. We did receive a couple, so I'll start with, we had a question regarding whether the Remade Institute would be a fit for food manufacturers. And actually, Kevin Kelly unfortunately had to step out for a visit from the Department of Energy, which is an important part of this whole equation. But he did respond to me that the most direct possible application area concerning food manufacturers for that institute would be from a packaging perspective. And so he would encourage food manufacturers concerned with sustainability to reach out to the Remade Institute about that.
So I'm sitting with Allison as well. So from a food manufacturer, there is another opportunity where the waste that's generated is very high in organic, and that can be used to fuel anaerobic digesters to generate methane, which in turn turns to electricity. So that is another opportunity for food processing facilities.
Thanks, Adrian.
Hi, Allison, this is John Wen. Could I just chime in a little bit on that too?
Absolutely.
Yeah, food processing is also a focus area for the ARM Institute. For depending on type of food, you may be slippery, may be flexible, may be in different shapes. Especially for this unstructured type of food processing and handling, developing robotic technology and automation technology with that is very much an emphasis of the institute.
All right, thanks,
John.
John.
On the topic of food. Yeah, since we're on the topic of food, this is Scott Miller from NextFlex. It's not exactly food, but ag tech, agricultural technologies, is one of the application spaces that gets talked about a lot for flexible hybrid electronics. The notion of being able to distribute very low-cost sensors that are produced and sensor devices complete with communication that are produced using flexible hybrid electronics technologies is one application. And then another is being able to track produce or other food from its origin all the way through its final distribution is another.
Mm-hmm.
Awesome. Everybody wanted a piece of that one. So food manufacturers have a lot to potentially gain from engagement with multiple institutes. John, we have another question for you from a manufacturer that is interested to know how they can get engaged with robotics-related workforce development resources, even if they're not in New York State.
Sure. ARM Institute places great emphasis on the education and workforce training. So that we can certainly connect you with the ARM Institute as well as with our current effort. So just now I mentioned a project call for technical projects. There's also a parallel project call for education and workforce training. In fact, we just submitted a proposal together with Dural Workforce in New York City in response to that education workforce training call. And the idea is not to have this isolated activities across the country, but to develop a common base and common repository of technology experience and shared insights so we can help each other out. So I will encourage whoever's interested, wherever you are in the country, to contact me, and we can get you connected with the rest of a EWD team in ARM, as well as connecting with our own effort in this area.
Hi, this is Adrian Cosmo with SESME, and I want to follow up with this to state that the embedded staff is here to become essentially like the quarterback for any manufacturer, whether you are New York based or based anywhere throughout the country. we're here to help you and help you find the right resources, whether it's Sesame, whether it's ARM, whether it's Remade. So that's the role that we play as a team. And so although this is New York focused, I can help and work with any manufacturer throughout the country and connect them to any institute that would make the most sense for them. So that's kind of what the role of the embedded staff is in this process. So thank you.
Thanks, Adrian. When Adrian says embedded staff, we're referring to those personnel who are with the Manufacturing Extension Partnership, specifically charged with being liaisons between the actual institutes and the U.S. manufacturing base, which is primarily composed of small manufacturers. We have a question for Terry, and it gets a little technical, so I apologize if I can't pronounce these things right. When it comes to integrated photonics, I'm glad we have Terry on the team to be the expert. We know that there's this test assembly and packaging facility being set up in Rochester. In general, I thought it might be good to have you elaborate on that a little bit and what it will offer small and mid-sized manufacturers. And then we did receive a specific question from an attendee. How advanced are the test assembly and packaging facilities services for low-cost, very high production of SIPH modules with single-mode fibers for telecom? And if you don't know the answer, how can that person find out?
Okay. All right, so first, a little bit overview of the test assembly and packaging facility. It will have a ribbon cutting, I would think, at the end of the first quarter. So that's the target. It will consist of 30,000 square feet of a combination of classrooms, clean rooms, and large labs for processing the integrated photonic chips. So the wafers will come from Albany and be sliced and diced in Rochester. And within that facility, there will be wafer scale, chip scale, fiber attach, both active and passive attachment of fibers, functional test, in-process test, and electronic surface mount assembly type processes. There's about $40 million worth of tools that are going into the facility as we speak. I think the facility will be the most advanced test assembly and packaging facility for integrated photonic chips in the world. And I'm not boasting, I believe that to be true. And again, I think that one of the major issues will be the fiber attach. And so think of a fiber which might be 1/5 the diameter of a human hair being aligned with V-grooves, for example, to a light source so that the information can be transferred from the chip to the fiber. And there are, I can give a very detailed presentation to the person that's asked the question. I have a specific presentation around the TAP facility and can show the equipment and can show the process flow for any type of assembly. And then, of course, Ed White, who's the vice president of the facility itself, can address very specific subjects as being the sort of the subject matter expert. But so I'm not sure if that addresses the question specifically or not, Allison, but I'll stop there and see if there's something else.
Thanks. We'll go ahead and make the connection after the webinar to see if there was any need for more information on that. I think we have time for one more question before we wrap up. I just wanted to note that, as you can see, some of these institutes are concerned with technologies that are really broadly applicable to manufacturers of all kinds. For example, smart manufacturing, really any industry. Robotics has applications across a lot of manufacturing industries, while other institutes are engaged in advancing technologies that are really creating new industries or transforming some specific industries. I think about AIM Photonics with respect to that, and perhaps to a certain extent NextFlex. So on the topic of SESMI, the Smart Manufacturing Innovation Institute, which is so broad in its application to manufacturers, how does manufacturer know which way to sort of enter the Institute's world? Are there groupings of such manufacturers?
SESMI is one of the newer institute that was created, and one way small and medium-sized manufacturers can engage is through affinity groups. So there is a membership component to SESMI, and the institute is evolving, and they realize that small and medium-sized manufacturers can't afford to necessarily pay the membership fee. So depending on the size you are, you can join at the regional level. But one of the great benefits that's available are these affinity groups that are being created to help small and medium-sized businesses look and network and collaborate with the bigger players in their space, and kind of create this ecosystem of support and resources that are available. That's just the most common way that small and medium-sized businesses can engage today.
Thanks, Adrian. Okay, so after this presentation concludes, you'll be able to find a recording of it and a PDF of the slides at the link you see here on the website. And I just wanted to close by saying that if you've heard things today that make you think that your company can benefit from adopting new processes in these areas, or has something to offer in these new industries and their supply chains that are being generated by their work, hopefully now you know who to get in touch with. These panelists all stand ready to assist you in getting engaged, whether it's through membership or some kind of other interaction. Just a call to action, beyond contacting the panelists themselves, again, FuseHub's mission is really to route New York State manufacturers to the right resource wherever it is. So if you don't know where to start, you can always go to www.fusehub.com and submit a request, and you'll get a live person calling you within 24 to 48 hours to understand your problem or your opportunity. And our solutions matching team makes it their business to understand the breadth and depth of these resources and make connections on your behalf. And I would like to also note that courtesy of the National Institute for Standards and Technology, Empire State Development, I'm sorry, I don't have a slide about this, it somehow dropped off. We do have a handful of grants available up to $50,000 each that manufacturers or nonprofit organizations can apply for if there's a project in which a manufacturer in New York State is going to benefit from adopting or advancing a technology in one of a handful of areas represented by these Manufacturing USA institutes. When we post this, the slides, we'll go ahead and add a slide that has that link on the Empire State Development website. And with that, thank you everyone for tuning in today. We hope you found it valuable. We're very excited to bring these resources to more manufacturers across the state and across the country. And thanks also to our presenters. Have a great afternoon.